Hello, everybody. This is Caleb,
And this is Brian.
and today we're going to talk about the Swift programming language and what we've learned while studying its components. Swift is a really important and interesting language to learn, especially if you want to have a future in Apple software development or application development in general. It is a high-level language that reads like English, kind of like Python. It is a simple language to learn that has many interesting features. By the end of this presentation, you should have a good grasp on the coding mechanics and syntax of the language, which will hopefully push you to learn more about it. Swift is the latest predecessor to C and Objective-C, Apple's previous language. It was developed and released in 2014, where it quickly gained popularity amongst the community. It is a language native to all of Apple's products and operating systems. These include iOS, macOS, and watchOS, to name a few. Since it is native to Apple, it is a language that is only available on Xcode and on macOS. It is also an open source language, allowing for the community to develop different tools to better help with their needs and just make quality of life changes themselves to update the language and make it run a little bit better. Now, why has Swift become so popular and demanded, besides being released by Apple, of course? It's because Swift has several perks when it comes to learning and coding in it. It is a fast language, thanks to it being statistically typed, and it has a wealth of documentation and resources, thanks to it being one of the largest communities for a specific language. According to Stack Overflow, it is the 10th largest community on the website. And finally, it is a language with high demand. Companies know that applications made for iOS versus Android have a higher success rate. Therefore, pouring more resources into acquiring capable developers to fill the role and make their product to reach a wider demographic. Swift's creation began in 2010 whenever Chris Lattner decided to start developing it. Here he's pictured on the right speaking at FOSDEM 2011. It was later presented in 2014 to Apple's Worldwide Developers Conference, where it was further developed by Doug Greger, John McCall, Ted Kremenek, and Joe Groff. The first release was on September 9th, 2014, and then after that, it had two minor releases with Swift 1.1 and 1.2 before Swift 2.0 was released on September 21st, 2015. In that same year, it became open source, and that's when Swift really took off and started reaching the masses.
Now that we speak a little bit of Swift and its history, let's go ahead and look at some of the data types that Swift offers. The first data type that we have is int and uint, used for whole numbers. Then we have float, which is used when floating point values must be very large. Then there's bool, which represents a Boolean value of either true or false. String, representing an ordered collection of characters, for example, hello world. Then we have character, representing a single character string literal. It could be A, B, C, etc. And optional, representing a variable that can hold either a value or no value. And finally, tuples, used to group multiple values into a single compound value. And at the side, we can see the data types along with their typical ranges and the typical bit width. Now let's go ahead and look at the collection types offered by Swift. The array is an ordered collection of values with a general form. It can store values of the same type in an ordered list, and the same values can appear multiple times and at different positions within the array. Then we have, array has the following general form, and then we have set, which stores an unordered collection of unique values, can be used to ensure an item only appears once, or when order does not matter. And then we have dictionary, which stores an unordered collection of key value associations, essentially storing associations between keys of the same type and values of the same type in a collection with no defined order. The image below really helps visualize these associations within a dictionary. Next, Swift has a very familiar system of commenting that is seen within C++. We have the single line comment, which works the exact way as C++, and that it is written the same as well. Then we have multi-line comment. It's the same story, same general form and function, making it simple for those familiar with C++. Now, where Swift differs is with its use of semicolons. In Swift, semicolons are optional and they're not required. It will compile and run the code if decided to use semicolons at the end of each statement. But semicolons are required when trying to write multiple separate statements on a single line. Now let's look at Swift's control flow. We have our first statement, the for in loop. The for in loop is used to iterate over arrays, dictionaries, ranges, strings, and other sequences. The general form is shown, which is similar to for loops in other languages. The example on the side is a simple for in loop iterating an array of names and printing a short hello followed by their name. It does this until it reaches the end of the list. Swift also has a while loop statement, which performs a set of statements until a condition becomes false. Evaluating its condition at the start of each pass, the general form is also familiar and similar to C++, with while followed by the condition, a curly brace opening, a statement or statements inside of the curly braces, and then closed off by a closing curly brace. Then we have the repeat while loop, which is very similar to the while loop, but instead the repeat while evaluates its condition at the end of each pass-through. Everything else remains essentially the same, running the loop until the condition becomes false. The general form is different as well, with a repeat, opening curly brace, statements inside, a closing curly brace, and a while followed by the condition. Visually, this is useful, having the condition at the end, aligning with the condition being checked at the end of each pass-through. Then we have if and else statements. The if statement alone has a single if condition that when evaluated to true runs a set of statements within the if's curly braces. The else statement is ran only when the if condition is false, and then in combination they can be chained multiple times to consider different outcomes. The general form is similar to C++ and is a useful set of statements to evaluate conditions with only a few possible outcomes. Now, switch statements is better for a more complex set of conditions. A switch statement is made up of multiple possible cases, each beginning with the keyword case, as shown under general form. It considers a value and compares it to several possible matching patterns. Once a matching pattern is found, it will execute a block of code based on the said matching pattern. It does this to the first matching pattern it finds, and if no pattern is found, it has a default case to consider an outcome that doesn't match the other cases. Swift also provides function parameters with return values. The general form for a function definition is func definition followed by curly brace, followed by statements, then followed by return parameters, and then closed off with a curly brace. In the example on the side, we see the function greet with one input parameter, a string value called person, and a return type after the arrow of string. Inside the function, there is a string definition with the return type being that string. To run the function with certain output, you would use print and call the function inside the print with the string value to be used for person. Therefore, in this example, it would print hello Anna. Swift is of course also home to basic operators. First one being the assignment operator, shown as an equal sign, where it initializes or updates the value of x with a value of y. In the example, b is defined and initialized to store 10. Then a is storing 5. Then at the end, a is assigned the value of b, therefore a is now equal to 10. Then we have arithmetic operators, which are standard for all number types. They read just like you would anything else involving basic arithmetic. The only difference between operators in C and Objective-C is that in Swift, they don't allow values to overflow by default. The next operator is the remainder operator, shown as a percentage sign. Using the example on the side, we can see that it works out how many multiples of 4 will fit inside 9, and then returns the value that is left over, and the example being 1. The next set of operators is the compound assignment operators. Essentially combines the assignment operator with another operator. In the example, we have a initialized to 1. Instead of writing a is equal to a plus 2, by using a compound assignment operator, we shorthand it to a plus equal to 2, increasing readability and ease of access, effectively performing both tasks at once. The next set of operators are the comparison operators, used to compare between two values. It returns a bool value of either true or false to indicate whether the statement is true, often used in conditional statements such as the if statement or while statement. The next set of operators are the logical operators. These operators modify or combine the Boolean logic values of true and false. First, we have the not operator, which inverts the Boolean value, making true become false and false become true. The AND operator, seen next, creates a logical expression where both values must be true for the overall expression to also be true. And then the final operator, OR, creates a logical expression just like the AND operator, but instead only one of the two values has to be true for the overall expression to be true. Then we have closed range operators, which defines a range running from A to B. The example on the side shows the for loop iterating through all the values within the defined range from the for loop definition. Next is the half-open range operator that runs from A to B, but does not include B. The example on the side shows the one-sided range being defined so that the for loop only counts as far as 3, which is the index of the last item in the array, instead of counting to 4, which goes outside the array. And the final range operator is the one-sided range operator, which continues as far as possible in one direction. For example, the last code example shows the for loop starting at the second index of the array and continuing until it reaches the end of the array. It can also be done the other way, going up to the second index of the array.
Up next, we have object-oriented programming, and as we've seen with the rest of this code, Swift pulls heavily from other coding languages like Java and C++, and the structures and classes which make up object-oriented programming isn't much different either. As we can see right here, we have the structure, we have class, and then we have the objects that allows those classes to be used inside of the main code. So right here, we can see that resolution is made up of width and height, and then video mode has all of these variables as well as the function print hello, and then TV implements video mode as a nested class. Now, to get the use of these, we have to create the objects down here as constant variables to make up the class and the structures. And we can see that it's populated with the dot syntax, again, taken from the likings of Java and C++, which is very interesting. So the dot syntax allows us to reach inside of the class or the structure, depending on which one it is. And in this case, we create some objects that aren't populated. Then in this case, we populate the some video mode object with the width 1280, and then we print out the hello statement. Then we print out the width of some video mode, and that can all be seen over here. We can print out television's color, and then television can reach into video mode since it is that nested class of video mode. And lastly, with VGA completely populating its resolution with 640 and 480 to both height and width, which is really interesting. And then next up, we're going to get onto the multiple return values. These are going to be some highlights that kind of showcase everything that Swift has to offer. And this is really cool and what sets it apart from things like Java and C++. A person is able to return more than one value as a compound return based on the tuple type. In this example, the function receives an array of integers and allows a compound return of integers in the form of minimum and maximum into the min and max variables. The return for min would be current min, the return for max being current max. The return also allows a user to return more than one return type in each compound return. So a person would be able to return both a string and an integer. It doesn't both have to be integers. And that's really interesting because we would be able to return both a person's name and age. One rule that does need to be noted is that compound return type has to be typed in one line and in one return statement. So that's right here at the bottom, return current min, current max. You have to do it in that one return statement. Next up, we're going to talk about a couple of highlights that we'll be using inside the demo, just so you have an idea on how they work exactly. So a guard right here acts as a body or a wall for the rest of the function. And what that means is it basically acts as the opposite of an if statement in that it forwards to an else statement if a condition is not met. In the example, the greet function is called. It prints the hello John statement this first time around because the person is populated with name John. So that print statement works because it passed the guard let name equal person name else. The second print statement doesn't work, however, because there's an early return. This early return is called because, again, it wasn't populated with location. When greet is called again, however, with print person name Jane location Cupertino, it works because location is populated with a location value. The guard statement is less descriptive than if statements, unfortunately, because you're not able to say if variable not equal to, and then adding the and statements that we saw with the basic operators. You're not able to do that with guard, so it's not as descriptive. However, whenever you read this, it says guard location if person does not have a location before moving on to the else statement. It's easier to read this because the else is always next to the value that is being checked. The guard control flow also allows a function to exit early. If a parameter is out of scope, the function is returned then before getting to the bottom of function, which helps out tremendously. Another demo highlight to talk about is the use of underscore. The underscore is a brilliant use of control flow in Swift. The underscore denotes a redundant use of a variable. If a variable is not used, a programmer can replace it with an underscore. An extremely interesting use of this could be inside of for loops, whenever I or whatever variable is being used for the for loop has no use inside the loop other than being used to iterate through it. In the first example on the page, the for loop calculates the power of a number when given the base and power. The iterable value variable, normally I, is not used in the loop, so it's denoted as an underscore. An underscore is also used to pass parameters to functions so that a programmer does not have to indicate argument labels. And that'll be inside of the print sum statement here, the second example. The underscore replaces the argument labels of x colon and y colon inside of the func sum underscore x int. That underscore replaces that. And what it does is you don't have to populate print sum 10.5 as print sum x colon 10 y colon 10. The underscore calls those automatically and it populates what x and y is inside of the function. So that's really cool to see. Next up, we're going to see the differences in both C++ and Swift in this case. So early on in the code, we're going to actually have a walkthrough of the code altogether. We're just showing right here that C++ takes 83 lines of code right here, and then Swift only takes 73 to print out the same thing. So the writability is just a little bit easier by approximately 10 lines. So that helps out quite a little bit. And we're going to move on to the code here real quick. So pulling up everything. Now we have comments right here just to help everything look a little bit smoother, just call everything out. So right here with the demo highlight, we showed the underscore. The underscore in this case is used to omit the argument labels. That is, the variable will not have to be put inside of here whenever it's called again. So we no longer have to populate it with array because the underscore is being used. And then the same thing will be noted whenever we see the function called the first time. And then the other demo point being this guard. So our medium implementation in this case was merge sort. So what merge sort does is it continues to split the array in half until it gets down into just one array, because it continues to split it until it's just the one, and then it merges it back. So this is saying guard array if it's greater than 0, then you continue, else you have to return it, and then the recursion starts happening to where it starts merging everything back together with the return merge left array right array. And that's really cool to see. So coming down here, we can see the function merge, again, it uses the underscores. So whenever it's called, we do not have to populate left array with left array or right array. And that helps out quite a bit. And then coming down, we can see here another important part of Swift is how to declare the array. So ordered pile will be the array that's initialized to store the other ones whenever they're merged back together. And it's created as an integer array type that has not been populated with any values. And then coming down here to the bottom, we're going to start with the original array that we create. And then the let value right here means that sizing will be a constant variable. So it will not change, and it's been initialized at this 100,000 value. And again, the underscore, denoting a redundant point, we can be able to separate this value into 100,000 without it being all bunched up together, and the code still runs. So that's really awesome to see. And then in here, we're going to use the for loop. So again, the underscore, I would be useless in this case. So the underscore replaces I, and then we populate the array with a random between 0 and again sizing 100,000, and we append that to the array. Then lastly, we ran this code 10 times, so that way we would be able to get an average time. So that way it's not just, oh, we run it one time, all it is however many milliseconds. We wanted to get a good average so that way the reporting would be more accurate. And in this case, Swift uses dispatch time as its timing source, and we were able to take everything down and just put it into milliseconds. So going back over to our code, our PowerPoint, we'll be able to talk about everything in contrast to each other. All right, so right here, we're able to see a couple of things actually. So in C++, the comparison shows us that C++ outperforms Swift by quite a lot. So 10 times in C++, it was 720 milliseconds, the average time being 72, whereas Swift had 35,875 milliseconds, which on the average run was 3,587 milliseconds. Also, something that is notable is that the Swift compiler printed out a warning showing that the merge sort is unused and that the sorted array isn't used after the sort takes place. So this isn't an error that's thrown to stop the code. It's just letting the programmer know that merge sort was never used. But in our case, we only used it to time the merge sort. A direct comparison of these languages can show the pros and cons of each. For readability, C++ is definitely harder to read. It has complex syntax and specific rules that the reader has to kind of see to decipher it. Swift is more English in nature since it is drawn from the C-based language, from Python and from Java, with the English nature being that of Python. Therefore, its readability outperforms that of C++. For writability, C++ takes longer to write by about 10 lines. However, the decreased strictness of syntax and its use of variables makes Swift much easier to write. Both sets of code for C++ and Swift are reliable in that it's easy to check for errors and there are no bugs for either sets of code. Time-wise, again, C++ definitely outperforms Swift, but Swift either ties or exceeds C++ in every other category. And here, we're just going to talk a little bit about where we got all of this code from. So Apple is the one that does develop this code, and then the developers doing the code do send it off to Apple so that way it can get used. So their official website that talks about how Swift is used has provided a lot of information, especially about its data types, its control flows, its basic features, its highlighted features. All of that can be found at this first website if you ever want to get into Swift and start looking it up. And then the second website, we took a figure from it. It just talks about how the underscore is used, goes more into detail on that. With this last one, it's just all about the history of Swift, and you can go take a look at that if you would like to know more about the history itself. And then we took the merge sort code from GitHub, and we took the C++ code off of includehelp.com. If y'all would like to go take a look at both of those just to be able to see how they work. Thank you everybody for watching. We hope that you may have learned something here and that Swift sounds like a really incredibly useful language to learn and that you would love to get to know it. So just thank you for watching.